The concept of the modal class. Welcome, everyone. Let's begin our discussion on the concept of the modal class. Now, if you recall from our previous lesson on ungrouped data, finding the mode was quite straightforward. It was simply the value that appeared most frequently in your list. However, things change slightly when we move into the realm of grouped data. In this context, our information isn't listed as individual numbers, but is instead organized into class intervals, such as 0 to 10 or 10 to 20. Because of this organization, we run into a bit of a challenge. We can't pinpoint a single, specific, most frequent value just by glancing at the table, because the individual data points are tucked away or hidden within these intervals. So, how do we tackle this? To solve this problem, our first step is to identify a specific range, which we refer to as the modal class. We will explore exactly how to find this in the next few slides. What is the modal class? The modal class is simply the class interval that has the highest frequency. In other words, it is the group or the range that appears most often in our table. Now, think back to what we learned about ungrouped data. Since the mode represents the most common value in any dataset, it is logically expected that the actual mode will lie somewhere within the interval that contains the most observations. If a specific range has the most items in it, that's where our most common value is hiding. However, I want to be very clear on one distinction. While the modal class gives us the neighborhood where the mode resides, the modal class is not the mode itself. To put it another this way, the actual mode is a specific, single numerical value located somewhere within the boundaries of this modal class. We have found the right area, but we haven't pinpointed the exact number just yet. Now that we understand why we can't simply pick a single number from grouped data, let's define exactly what we are looking for. In the next slide, I'll show you a real-world example of how this looks in practice. Real-world example: weight of parcels. Now that we understand the theory behind what a modal class is, let's look at a practical, real-world example to see this in action. Imagine you are working for a courier service. To optimize the loading of their delivery vehicles, the company has recorded the weights of 50 parcels. Because there are so many different weights, instead of listing every single parcel individually, the data has been organized into a frequency distribution table. Take a look at the table on the screen. On the left, we have our weight intervals, measured in kilograms. On the right, we have the frequency, which tells us the number of parcels that fall into each specific weight range. For instance, we can see that 5 parcels weigh between 0 and 10 kilograms, and 12 parcels fall within the 10 to 20 kilogram range. As we move down the table, we see the weights of 8 parcels between 30 and 40 kilograms, and 3 parcels between 40 and 50 kilograms. Now, as we move to the next slide, I want you to keep a close eye on that middle row, because that is where the most important information lies for finding our modal class. Step-by-step process to identify the modal class. First, we begin with step 1, examine the frequency column. To do this, you shouldn't look at the weight ranges just yet. Instead, I want you to focus your eyes on the number of parcels column, which represents our frequencies. We are searching for the largest number in this list. If we look at the values provided, we have 5, 12, 22, 8, and 3. As you can see, the maximum frequency is 22. Moving on to step 2, we need to locate the corresponding class interval. Now that we've identified 22 as our highest frequency, we look directly to the left to see which weight range that number belongs to. By looking across the row, we can see that the frequency of 22 corresponds to the class interval of 20 to 30. Finally, we reach step 3, where we define the modal class. Because the interval of 20 to 30 is the one with the highest frequency, we can officially conclude that our modal class is 20 to 30. Now that we have our example of the parcel weights on the screen, let's walk through the actual process of identifying the modal class, step by step. It is important to remember, as we will see in the next slide, that while we have found the correct interval, we haven't found the exact mode yet. We have simply found the neighborhood where it lives. Conclusion. So, let's wrap up what we've discovered from our parcel example. Based on our analysis, we now know that the most common weight of the parcels, which is what we call the mode, is a specific value that falls somewhere between 20 kilograms and 30 kilograms. Now, keep in mind, we haven't pinpointed the exact weight just yet. We've only identified the range. To find that precise, exact numerical value, we would need to move beyond simple observation and use a specific mathematical formula designed for group data. Don't worry if you aren't familiar with that formula yet, because we are going to cover that step by step in our very next subsection. Key takeaways. First, let's look at the difference between grouped and ungrouped data. Remember what we discussed at the very beginning. When you have ungrouped data, finding the mode is easy. You just look for the number that appears most often. But, as we saw with our parcel weight example, when data is grouped into intervals, you can't just pick a single number by looking at the table. You first have to identify the modal class. Next, let's solidify the definition. It is very important to remember that the modal class is simply the class interval that possesses the maximum frequency. It is the category with the highest count. This leads us to the purpose of finding it. Think of the modal class as your starting point or a neighborhood. It doesn't give us the final answer, but it narrows down our search, telling us exactly which interval contains the mode. Finally, I want to emphasize a crucial distinction that often trips students up. The modal class is an interval, such as 20 to 30. However, the mode itself is a single, specific numerical value, such as 24.5, which lives somewhere within that interval. All right, let's take a moment to recap everything we have covered in this lesson, so we can ensure these core concepts are clear before we move on to the calculations. Keep these distinctions in mind, because in our next lesson, we will learn the specific formula used to pinpoint that exact value. Common mistakes to avoid. First, be very careful not to confuse the frequency with the mode itself. This is perhaps the most frequent error I see. For instance, looking back at our parcel example, a student might look at the highest number in the frequency column and incorrectly state that the mode is 22. Remember, 22 is simply the number of parcels in that group. It is the frequency. The mode must be a weight value, which we know lies somewhere within the 20 to 30 kilogram range. Second, try not to confuse the modal class with the mode. It is easy to identify the modal class as the interval, such as 20 to 30, and then mistakenly assume that this entire range is the mode. As we discussed earlier, the modal class is merely the neighborhood or the category where the mode resides. The mode is a single, specific numerical value hidden within that interval. Finally, don't ignore the interval itself. When you are working through these problems, always ensure you are looking at the frequency column to find that maximum value. But when you write down your final answer for the modal class, make sure you are reporting the corresponding class interval. Now, before we wrap up today's lesson, I want to pause and highlight some common pitfalls. Even students who understand the concept can sometimes trip up on these specific points during an exam. If you can avoid these 3 mistakes, you will have a much stronger grasp of this concept as we move into our next lesson, where we will learn the actual formula to calculate the exact mode.